Today we are going to talk about a topic that is very near and dear to my heart, which is how do you build an internal developer platform? And this is, I think, a very interesting thread that has been developing the last few weeks and months in the platform engineering community. There were a lot of conversations about it during PlatformCon a couple of weeks ago, and in general, I think it reflects one of the maybe more ancient debates in the space, which is like portals or other solutions, and in general, like how do you build an internal developer platform, right? At the end of the day, this is an example of what you might want to end up with, right? This is specifically an internal developer platform for a multi-cloud setup. This is built on AWS and GCP. And, you know, this is usually what enterprises strive for, right? Like this reference architectures have now become really the sort of the blueprint and the standard for how a lot of teams, especially large teams, think about building these things. But this is really the end goal. So the question is like, how do you get there, right? Where do you start? And again, if you zoom in, right, you can basically see there are five different planes, right? We have a developer control plane, an integration and delivery plane, monitoring, security, and then you kind of like your resources infrastructure sort of plane, right? Now, obviously, a full-on internal developer platform has all of these things, but when you start building, usually, and this is really what we see in the vast majority of platform engineering initiatives, it's either one of these two, right? So it's either the front end, right, effectively. So you could even think of the developer control plane as a front end and the integration and delivery plane as your backend. And what's interesting here is that building an internal developer platform is effectively like building any other application, right? You have this front end, your back end, and then maybe you have some components around it, right? And so now the question is, again, should it start from the front end? Should it start from the back end? Obviously, as you might have guessed from the title of this talk, it's we're going to focus on backends and backend designs. But the question is still, why not front end, right? So I want to address that first because, as I mentioned at the beginning, there's still a lot of, I think, confusion around this in the space, and it's still one of the oldest sort of debates and conversations and questions in when people approach platform engineering. But unfortunately, it's still very unclear to a lot of newcomers to the space, but also people that have been around for a while. And so if you just address that question for a second before we get to the back end stuff, it's okay. This is the front end, right? But really, when we talk about front ends, in the vast majority of cases, right, we're talking about portals, right? We're talking, and obviously the OG here is Backstage, which was open source by Spotify, I think 6+ years ago. And this is the thing that always people thought, okay, well, I want to do platform engineering. Let me just, slap some nice portal on top of my existing setups. Boom, off you go. I'm doing platform engineering. And the point is, it's not that easy, right? If you think about what a portal is, right, and this is a definition by Gartner, an internal developer portal is effectively the interface, right, that you use to access the platform capabilities. So, and this is a first important differentiation, right? A lot of times, and obviously, the abbreviation here is not very helpful because it's IDP and IDP, right? Internal developer portals, internal developer platform. We're not going to get into the why and how, and that's just an unfortunate coincidence. Let's call it that. Let's call it that. But the point is, you now have this confusion in the space of like, okay, an internal developer portal, an internal developer platform, are they the same thing? No, an internal developer portal sits in the previous layer, right? In the top layer in the front end, and it's just a component of your internal developer platform, right? So your internal developer platform is the whole thing. The portal just sits on top and is one of the interfaces to your underlying internal developer platform. Now, this is very, very important, right? Because and here you can see it. This is actually like a Gartner graphic, right? They have like a bit of a different ways to think about of visualizing platform. But as you said, I mean, the standard basically at this point is this reference architecture that I showed at the beginning. The point is developer portal sits on top, right? And so what is the issue with that? And I think this is very, very important. And I often return to this article that was written by Aaron Erickson, who is the guy that built the internal developer platform at Salesforce. This is almost a decade ago at this point. And he wrote this article on platformengineering.org, I think like 3 years ago or so, where he was basically using this, I think, very, very helpful analogy, which is, hey, building an internal developer platform is like building a house, right? And the reality is that when you want to build a house, you start from the foundations, right? You wouldn't start from the windows or the door, right? And that's a little bit what you do if you start with the front end, right? Is you kind of put your nice little door first, and then you try to build the house around it. And this breaks, right? And while it might seem, right, that you're getting this sort of like head start in your platform engineering journey and you're doing all these things and it's fantastic and so on, the reality is that you're basically creating debt, right? You're creating tech debt. And again, we're all familiar with this idea, right, of building applications. You always want to start from the back end, not from the front end. And if you do start from the front end, right, you have a very nice thing, right, that you can look at right away. But then as the complexity of your application grows, you're trying to shoehorn more and more logic into the front end, which is really not built for that. And that's exactly what we see here in platform engineering, right? If you start from the front end, you have these issues where all of a sudden it's like, hey, but how do I keep, adding policies? How do I make this thing more secure and so on? And then you're doing a weird reverse engineering that doesn't really work, right? This also breaks the single responsibility principle, which is, if there's anything that we've learned from microservice architectures in the last decade plus, is that a front end should just be a front end and a backend should just be a backend, and you should not try and have them do different things, right? And then on top of that, you have this problem that you're really exposing a lot of your business logic and potential vulnerabilities through the front end if you try to squeeze in the logic in there, like what's supposed to be your backend logic, right? So again, I don't want to harp on this too much, but I think it's important to reiterate, portals are an incredibly important part of platform engineering. And you have Backstage, which has been around forever, and it's really one of the OG players in this space. And we wouldn't be here without the role that this type of product played in the space. But it's very, very important that you understand, if you're building a platform, start from the foundation of the house and then worry about your doors and your windows later. Okay, so just wanted to clarify that. Now, how do you build a backend, right? Like, you want to start from the foundation, that's fantastic. What options do you have? And effectively, you have two options, right? This is really, like, I think, out of maybe 300 platform engineering setups that I've seen in the last 12 months, really 99% can really be clustered in two groups. One is what I call pipeline-based backends. Not just me, in fact, most people call them that. And this is effectively, if you zoomed in, and sort of, again, if you go back here, right, this again, the integration delivery plane, we're zooming into that part, right? And so here's where you basically have your CI, your CD, right? So you have something like a GitHub action, you have an image registry, you have a CD, and then maybe that the sort of CD tooling is then connected to your crossplane if you're working on Kubernetes, some IAC, whatever it is, right? Fantastic. That's what pipeline based looks like, right? And the thing about pipeline based, right, is that most teams are used to it, right? It doesn't really require too much change. We all have, at the end of the day, some sort of CI/CD solution in place, right? But here's the thing. It is a start-stop system, right? It is designed really to have this environment progression logic in it, okay? And this is really, really important to understand. So as long as you have very simple logic in your platform where you say, hey, if this, then progress to the next environment, if this, then promote to the next thing, and so on, then it's fine. The reality, though, is internal developer platforms are meant to be used by enterprise engineering organizations. And when I say enterprise engineering organization, I mean hundreds of developers, right? And when you have hundreds of developers, tens of different development and product teams at a minimum, right? You really you can't just work with this simple logic. Anyone that has worked in an enterprise will know that you all of a sudden have all of this like governance and policy requirement. You need some sort of RBAC. You need some sort of like approval steps. And you start having this like self-referencing logic that you need to build into it that gets quite complex over time, right? A different user is requesting a database, but then there's another user that needs a different type of like admin rights on the same database or infrastructure or piece of resources or whatever, right? And so you end up very quickly in a place where you're nesting pipelines. And this is really the issue with this pipeline-based backend design. It is okay if you are, planning to have a very, very simple sort of setup for your platform, but it's really not okay if you are thinking about platform engineering the way it's supposed to be done, which is handling, hundreds, thousands of requests by different development teams that need different types of infrastructure, that need to have different permissions, where you have security teams that are worried about all of this stuff, where you have infrastructure and operations teams that interact with all these things and so on, right? And the problem is that, you quickly go from, right, just like a simple sort of, again, this progression logic, right? Step one, step two, you have somebody that manually checks. Step three, I'm calling some Terraform script in some Git repo, yada, 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 right? To this, more of this, right? Where you're effectively starting to have a pipeline nested in another pipeline that at a step calls this other pipeline, and then this has two steps, and then this calls another pipeline, and so on and so forth, right? This is really what happens when you go pipeline based first. And the issue with that is that while it might be a little bit better than starting from the front end, right? So good, you're at least starting from the back end of the platform here. The problem is you're once again taking a tool in the case of the portal, or here a set of tools in the case of the pipeline. Usually, sometimes you just have maybe one Jenkins that does most of the things, but the reality is that you're probably still going to have some like, IAC layered on top of whatever, right? And the thing is, you're taking this sort of set of this tool chain that is designed to really have this progression logic, and you're trying to make it do more complex things. And the problem with that is it breaks. And you're basically back at square one, where, what's the issue with trying to do everything in the front end is that it makes it extremely hard to maintain, extremely hard to scale, and it exposes the logic and all the other things that we talked about. When you go backend first is better, as I said, but when you go pipeline design first, the problem is you're just delaying the problem a little bit, right? Because eventually you'll get to this place where once again, it becomes extremely hard to maintain and scale with from an infrastructure and operations perspective. And from the development team perspective, they're still completely overwhelmed. They have, the cognitive load is not reduced at all, because they still need to understand all those different steps a lot of times, or need to, be able to go and tweak different configurations at different stages of this nested pipelines, right? And so you basically end up back to square one, where cognitive load is still high and maintainability, scalability is still very, very far away, right? And that, at the end of the day, those are the things that we're trying to address with platform engineering. So what is the alternative here is graph-based backends or platform orchestrators. And this is here a tool, friend of the community, and ambassador at CNCF, and this is actually a talk that he gave at the working group, at the platform working group. I believe this must have been in Chicago at KubeCon, but where he's basically describing, right, this idea of like, hey, what you need is some sort of orchestrating layer in the middle, right, where the platform team is setting the rules, right, of the game, is defining how resources are to be configured and consumed, and developers can basically just request things in an abstract way, and then the platform orchestrator matches those two things and figures out everything else, right? Which effectively means the developer, the cognitive load is reduced on the developer, and the entire setup is a lot more maintainable and scalable and standardized for the platforming teams, for the infrastructure and operations team, for the security teams on the other side, right? So let's double click on that for a second. And here I'm taking as an example Score, right, as the interface. Again, you could use any interface that sits in the developer control plane. This could be a portal like Backstage. We do find that in a lot of enterprise teams, people tend to prefer something like Score because it's code based and because they're familiar with that, right? Right now, effectively, if I'm a developer in a large team, I will usually have to handle YAML files, right? And so people are very familiar with this interface. The problem is that today in the enterprise, YAML files get really messy, right? They have a lot of implementation details hard-coded. So what people keep doing is just like copy paste one YAML file to the next and then tweak to whatever the thing they need, and then keep going like that, right? And what that creates in turn is this mushrooming of configuration files all over your enterprise. And again, that's a problem that we're trying to avoid here, right? So Score, the thing about Score is that it's environment and platform agnostic, and it really provides a familiar interface to developers, but a very simple one, very abstracted one. And by the way, this was donated to CNCF, and I believe it's almost officially got accepted as a sandbox project, which is very exciting. And so here you see, right, what I do from a developer perspective, I basically just say, hey, I have a service, right? It's called very creatively product service here. And it needs these dependencies in order to run. In this case, it needs a database of type Postgres, a bucket of type S3, and so on and so forth. Now, crucially here, I think it's really interesting to note, I don't have to specify anything else, right? I don't need to know as a developer which version of which Postgres, what implementation details, how much CPU for that one instance of that thing, and so on and so forth. Like, I don't need to worry about any of that, right? All I need to do is say, hey, I have a service, and it has these dependencies that it needs in order to run. Fantastic. So then, how does this work with the orchestrator, right? You have this idea of resource definitions, right? These are also YAML files that the platform team effectively uses to describe the rules, right? Of how this type of infrastructure, how this type of resources are to be consumed effectively. Then you have the Score file that we talked about. And so what happens is very simple. The developer basically says, hey, I have a product service. It needs a Postgres. And all they do is a git push, right? It goes through the CI and so on, right? So again, it follows that backend logic of the delivery, the integration and delivery plane. And what happens here is the orchestrator, right, which is the graph-based backend, and you'll see why graph-based in a second. But the orchestrator basically says, hey, I understand the context, right? I understand this abstract request for the developer. They need a Postgres. They haven't specified what Postgres or whatever. I understand what context they want to deploy to, right? So they want to deploy to, in this case, a staging environment or whatever. And so I go and say, okay, for context staging and resource of type Postgres, use this RDS instance resource definition, right? And then basically what the orchestrator does is it goes ahead and creates a graph-based representation of the application, right? Of your workload. So here you have your workload, right? In this case, you have a Cloudflare DNS, an EKS, and you have your RDS, right? So this is what we mean with graph-based, right? It means that it's creating this graph that basically gets built from left to right. You can think of, right, because like the orchestrator basically resolves all the different dependencies and figures out, and then it gets deployed right to left. Okay, what that means is, and again, this is a very simple example here, but you could also have nested logic that we're talking about, which gets very, very complicated with, for instance, with pipeline-based backends. But here you simply have, for instance, you would have like an RDS that is depending on another resources that maybe is depending on another resource definitions that actually lets you define the different roles for that infrastructure. So you can get extremely complex and go very, very deep. And basically all the orchestrator does is it creates this representation and then it resolves it right to left. So it starts deploying from the, kind of like the bottom pieces and components all the way up, right? This is how graph-based works. And this is why it handles this type of any type of complex logic, right? And so as an example, let's say now as a developer, I want to add a Redis to my workload, right? Interestingly, all I do here is, again, this is an example with Core, right? But you could use a portal like Backstage or whatever. You could just click a button, run a command in your CLI, whatever, an API call. In this case, you just add 2 lines of code, right? Cache of type Redis. And the interesting thing is, again, like the CI runs, the orchestrator understands, okay, for context staging, use this elastic cache Redis, boom, a new graph-based representation of the workload is created with the deployment, and then either handed over to an existing deployment solution like an Argo or whatever, or it's automatically deployed depending on what you're using there for your tool chain. But you see here, right? So again, this could have nested a ton of logic underneath it, right? That could say, well, actually, this is a Redis, but for this specific developer for this, or the development team for this specific environment, they only can do X, Y, Z, so it has some limitations built in and so on. But all of that complexity is completely shielded away from the developer, right? All they need to do is add 2 lines of code or click a button in the UI of your portal, off you go, right? So this is what platform engineering really looks like. It means really lowering the cognitive load of your developer while making your setup much easier to scale with and maintain. And I want to double click on that part in a second. The orchestrators, by the way, also manage progression between environments. So it's not like you're losing that sort of like pipeline progression-based logic, right? So in the case that we've just seen, you've seen like the git push, right, where then the resource graph is built. You generate then application infrastructure configuration files, right? These are like your Helm charts, your Terraform files, and so on. And then you can trigger any policy check that runs the check, a sign off, whatever. And then you move to staging. So you have that kind of progression. Then you have a success. And then, that success can then, you can hook into the orchestrator, whatever, like like your Teams or Slack notification, or it can update the portal back, like your Backstage, right? And then you eventually move to production and so on and so forth. So you still have that functionality, right? But it just allows you to build in a lot more deeper logic into your platform, right? And this is extremely important because this lets you follow golden paths, which is really what platform engineering at the end of the day is about, right? It's about this. It's about this idea that, like what we can see here, right? If I have, and this is the example that we looked at. I mean, we looked at Postgres, whatever, but like if you just need any piece of infrastructure for one of your existing workloads as a developer, all I need to do is add a couple lines of code. Again, if I'm using Score, what it means for this to be scalable and maintainable is that operations don't need to be involved in this, right? Your infrastructure and operations team don't need to constantly put out fires and fight ticket ops, right? And all this inbound requests by development teams. All you just need to set the rules, right, in the form of resource definitions once. Your security teams needs to check them once, and then you can sleep well at night because you know that the system will automatically enforce that, right? This is the same thing for an environment, right? These are things that in enterprises that I speak to every week, getting a new environment can take 2 to 3 weeks sometimes. It shouldn't be like that, right? It should just be a simple git push, and everything is automated, right? I think another thing that I want to point out, and why this is so powerful, right? It's not just about this kind of like developer self-service thing. It's also, again, in the with the idea of like maintainability and scalability, it's also from the flip side, right? From the perspective of the operations and infrastructure teams. Because let's say you want to update, resource X from VY to VY+1. Now, and I'll get to that to you in a second, Balaji. I've seen you. If I didn't know people could raise hands, by the way, that's pretty cool. But let me just wrap up this one for a second because it's really important. So if I want to update, Postgres from VX to VX+1, nowadays the reality of the enterprise is that the platform, infrastructure team, whatever they, however your org chart looks like, they basically need to go to every development teams and be like, hey, what version of this thing are you using? Okay, well, that's like 2 versions too old, or that's not the latest security vetted one, or whatever. Okay, let's update you. And then you need to work with them and update them and so on and so forth, right? And this can be a very painful process because you need to go one by one and so on. Now, again, here's the powerful of this graph-based approach. In the graph-based approach, you have a library, effectively, of resource definitions, of rules that the platform teams defines together with infrastructure and operations teams. And so all you need to do in this case is just update one file, right? You have one file per resource, per environment, effectively, and you just go update that one. And automatically, the next time a development teams or whatever is deploying and needs that piece of infrastructure, the latest thing is going to be used, right? Developers don't need to be involved at all in this process. Security maybe needs to vet it once, so maybe the meditation emoji is a little bit too optimistic here, but it's really once, right? You don't need to do this multiple times and always be involved and so on, right? This is the other thing. Why are golden paths so important is because you remove friction from the system. Like we see so many times that you have all this like back and forths, right? It's like, oh, I need this and I need that and you keep going back and forth, and you have like 18 different touch points between developer, operations, and security teams, right? And it takes 3 weeks to get something out, right? And so that's really what platform engineering is about driving automation while driving standardization, right? And I don't need to run through these other things. Okay, so before we get to this, shall we take the question from Balaji, Maria? I can't see anything on my screen.
Yeah, we can, but Balaji needs to type in the question in the Q&A.
Okay, well then we'll take that later. Okay, cool. So then, what are the pros and cons of this of this system, right? First of all, graph-based backends check all the boxes of good architectural design, right? It's API first, then supporting multiple interfaces, right? So it's modular. It has all the sort of kind of like enterprise stuff that you expect, and it still has this kind of like sign off and promotion logic that you built into that, secrets injections and so on. But it lets you handle much more complex logic, which is really what you're looking for if you are at scale. And that's kind of the point, right? It only makes sense at scale. I mean, if you're like 20 developers, you don't need this type of thing. You're totally fine with some sort of like, pipeline-based backend, or even with a pass, right? And again, for those of you that might wondering, like, wait, what's the difference here? Like, a pass, right, is usually like just get provided by a vendor, platform as a service, right? Provided by a vendor. The OG would have been Heroku. There are now many different ones that are kind of like very specific to specific use cases, like e-commerce or whatever. And these are great. These are great if you're like 10, 5 developers, 3 developers, 2 developers, 20 developers, and you just want to get started, right? They're great for greenfield use cases and so on. If you're bigger, usually you want to build an internal developer platform because you'll have specific requirements, because you have existing toolchains and so on. And if you're really an enterprise, you need to think about graph-based orchestration for your platform, because that's how you really scale, right? Now, the main challenge with that, really, I would argue, is this, right? It's a different way of doing things at the end of the day, right? We are all used to pipelines. We're all used to this kind of like progression sort of logic, and people just try to take what they're used to and make it work. That's at the end of the day how engineers think, right? Which is great, but sometimes it just it's to get to a next level of performance as an organization, it requires you to go to the next level of mindset and tooling and of thinking about how you can do things differently. And that's really, I think, the main challenge with graph-based backends. The important thing with that is, or how you mitigate that is through standards, right? And this is kind of like what I want to close on, which is what I ultimately really believe in when it comes to platform engineering, right? And this is something that I kind of that I sort of touched on throughout, right? But basically, I really believe that as a platform team, your value is in the last mile optimization, right? It's not in reinventing the wheel. So don't reinvent the wheel, please, because and this is something that I think happens over and over in our industry, which is something new comes up, and because it's new and not mature yet, like platform engineering, people, the people that are first attracted to it are kind of the early adopters and people that like to get their hands dirty and so on, which is great. But as it matures, and as really you have at this point, every serious enterprise engineering organizations out there is basically looking at this, right? It's really important that we also mature the way that we talk about these things, and then we think about designing platforms and rolling out platforms and so on. And what that means a lot of times is that you can't build the entire thing yourself, right? Nowadays there will be very few teams that say, hey, let me go and build my own database or my own Kubernetes clusters or whatever, right? You just take what's out there, whether it's open source, commercial, or so on, right? The problem with platform engineering is being new. There's still a lot of people that are like, oh, let me build everything on my own. And I honestly think in some cases it might apply. Usually in the very, very large cases, right, when it's like, hey, we are a platform team or 100 people serving like 5,000, 10,000 developers. I've spoken with a few of those as well. I think it makes sense there usually to basically build everything from scratch. But the vast majority of cases, the vast majority of enterprises, they're not really there, right? They have like hundreds or low thousands of developers, and probably like 5 to 10, 15 people, 20 people in the platform team, right? So you really need to pick your battles here, right? And I think personally, the value of a platform team is in that last mile optimization, right? So the way I think about platform engineering is you have this like huge toolbox of things out there, right? And hopefully what platformengineering.org and the landscape there, by the way, we're rolling out a new version in this, I think next week, that should be quite helpful for everybody. But hopefully that guides you, right? The Revs architecture guides you throughout, right? But it's still like a decent amount of tooling, right, that you need to figure out and so on. But the point here is you as a platform team want to look at this thing and basically say, okay, how do I combine it in a way that makes sense for my developers? And that's the key thing, right? the key idea of platform as a product is that you as a platform team are the only ones that actually know the needs of your engineering organizations. This is why, by the way, the PaaS that I was talking about earlier, the platform as a service, never works for the enterprise because there's no product team that can know what your needs are, right? Because they're different. And so the point is, good platform engineering tooling is tooling that a platform team can take and then adapt and sort of tweak to the specific needs of your engineering organizations, right? And the important way of doing that is by starting small, right? This, I can't emphasize this enough. And, I've been harping on about this for the last like 6 months or so, but really this idea of the minimum viable platform, right? And this idea of like, hey, you really need to start small and show value fast to all your different stakeholders and then iterate from there. If you don't do that, that is guaranteed death of your platform engineering initiative, right? I've seen this over and over and over again, right? Because people look at this internal developer platform or reference architectures, right? And they're like, fantastic. I am going to build this entire thing. It's going to be splendid. I'm going to do all these things and blah, blah. And, what do you know, 12, 18 months down the line, they're still there, right? Because the key thing to understand about platform engineering is that it's a very big org transformation. There's no hiding this, right? And so the way you do this type of org transformations is you need to get on board different stakeholders. You need your application developers, you need your executives, you need your architects, you need security teams, existing infrastructure and operations team, and so on, right? And the problem is if you want to do everything all at once, everywhere, like the movie, right? You basically need to convince all these people at the same time, and it's almost impossible because you'll talk to person A, B, C, by the time you get to person Z, person A, it's been 6 months and person A completely forgot about you, right? And so it's just really, really hard to keep that momentum going. And this is why this idea of this framework of minimum viable platform is so important, right? Because it forces you to say, first of all, what's the scope here? And you usually want to, you see, right? Like this is sort of like grayed out. You want to focus on really like the minimum scope here, right? You can worry about monitoring and security later on, right? When you really want to scale it up. But like at the beginning, what are the things that you want to show, right? What are the things that are important, right? And here is the key thing is to understand what are the sort of the key metrics, right? That your stakeholders care about, and you can identify a specific group of stakeholders, say application developers, right? They really care about the fact that, I don't know, right now it takes them a week to get an environment, or it takes them 10 days to get a new database instance to play around with code changes or whatever. Okay. Or, you focus on infrastructure and operations team, and it's like, hey, right now they have 10 new tickets per week of things that they need to resolve. It'd be great if that was like one, right? You don't even need to have like crazy quantitative metrics. You can also just have like very anecdotal, what do you care about? Like, what are the pain points that you care about? Okay, identify those in the design phase, then go and integrate everything and sort of like actually build it, your MVP, and then go demo it, right? Go really pitch it, to your stakeholders and be like, hey, here's how this as can improve your baseline. This can improve on the challenges that you kind of like identified in phase one, and this can take you like 4 to 8 weeks. Really, like I've seen very large enterprise organizations going through the entire MVP in a month, basically, and that is already puts them in a place where like, hey, they don't have anything production ready, of course. That's not the point. But they have now buy-in, right? People are listening. People start to see, okay, I can see how this can really help. And then you kind of iterate from there, right? So it's really, really important to think that when we think about platform engineering, we think about this last mile optimization. We think about standards, right? We think about the minimum viable platform. We think about reference architectures. We use tried and true blueprints, and really apply them to your own use cases. make sure that you keep showing value, right? It's really, really important. This is not just a technical challenge, this is a cultural challenge as well. And you need to get everybody on the journey with you. And that's it, really. Thank you so much. I don't know how, yeah, thank you. And let's open it up for questions. I don't know, we have, we have about 10 minutes or so, so let's go. Rock and roll.
Let's go. Thank you, Luca, for a very passionate talk as always. Let's start with the question from Balaji. Thank you so much for putting it here in the Q&A. Question was more on this golden pass, where core component changes are involved, especially similar to example of Postgres v14 to v15. It might not be very similar to, it might include doing multiple changes across drivers used. Lots of patches required across components. How this will work in such scenario?
Yeah, so what you do there, wait, well, I don't know if things connected. So what you do there, yeah, is you this is a simple example, right? In this example, you just update one configure it, one resource definition file, right? Which again is just like a YAML file. This is very simple, right? This is simplified. Obviously, in the reality of things, if you have a lot of complex requirements and a lot of complex logic, you would update more than one file, right? But the key thing here, and this is really the key thing, is nowadays let's say this example is, let's take a complex example, right? Instead of going to like one, if you don't have a graph-based backend, right, and you go kind of like one by one to the development teams, you would basically have to like have this like very complex conversation with each team effectively, right? The key thing here is the scalability and the maintainability aspect, right? So you do that once and it automatically gets rolled out everywhere. Now, you also have different rollout strategies. I mean, obviously it depends also on like how you think about orchestrating your platform and what you're using and so on. In our case, for instance, with the Humantic platform orchestrator, you actually have different ways that you can then basically deploy these changes, right, across different teams. So you could still say, well, team X still uses v14 in this example, and team Y is automatically going to move to v15 at the next deployment, right? And you can again like build more logic on top of that, right? So again, the important thing here to understand is what is your, if your use case, and it sounds like you're thinking already about pretty complex workflows there, Balaji. If you have that complexity in mind, you need to design with a system with that in mind, and that is able to handle that complexity from the get-go, right? And this is really for me the key message that I wanted to share with this talk, which is, it's very easy to kind of just like, okay, let's start and do things because we need to get going, but this is just always going to create tech debt. And the important thing is, if you have complexity in mind, if you know that you're going to have complexity, and even if you don't, and like this is another thing, by the way, that is like, I think is a big trap for a lot of platform engineering teams, which is they kind of like start, they either go one of two ways, right? They either go like, okay, let's do all the complex things, all the possible complex things first, or let's think about all the possible complex things that we need to do and design for all those use cases, which basically means you're not following an MVP framework and you're never going to go anywhere because you're still nowhere after 12 months. Or they basically go super fast, super quick, and they're like, all right, let's just do like a quick front end and then like show a dashboard to management, and that's going to be great, right? And you get stuck on the other end of the spectrum, right? And so the point here is like you wanna design your backend to handle any level of complexity, but then start small. Start from the simple use cases, and then you'll graduate to the things that you're talking about, Balaji. But yeah, I mean, the point from a technical perspective, strictly, the platform orchestrator can handle all of those things, right? You just need the beauty is in this resource definitions is that you can build any sort of logic there, right? That is like referencing each other, but you just do it with one file at a time, and you just need to update that one file, and you don't need to like worry about like, okay, I have like 100 different Postgres instances that are configured in 100 different ways in my staging environment. Like, how do I update that?
Yeah, it's crazy. Cool. Balaji, if you have any other follow-up questions, feel free to pop them here in the Q&A chat as well. Can you explain, and this is the question from a chat, can you explain once again how upgrades of resources doesn't have to involve ops and security teams? Imagine one product team needs to upgrade its infrastructure database or GKE cluster, but other teams don't have to. And second scenario, in case where all product teams should upgrade new released versions, how do you avoid running after devs to return their application pipelines?
Yeah, that's a great question. And I mean, we kind of touched on it on the previous one, right? But you depending on what orchestrator you use, again, like with the Humanitech platform orchestrator, you actually can design rollout policies for these type of changes, right? So you can say, hey, a given product team is already going to get access to the latest piece of infrastructure, and another one won't yet, right? So you have this like kind of like blue green type of thing, or canary, or whatever. There's different rollout strategies that you can have there, and the way you do that, right, is again just this is very simple resource definition files, right? These are really just like YAML files that have logic built in it in the form of like different criteria that you build in, and then that sort of like link to each other, right? And so that basically is then what then gets referenced by the orchestrator at runtime, right? When the graph-based representation of your workload gets built, right? Then the entire graph gets built, right, and then gets deployed. And so what the orchestrator effectively does is basically like piecing together all the different resource definitions, right, and build this direct acyclic graph, right? That's ideally what you want to have, right? Because it's something that kind of like just cycles into one direction, and that's how you the orchestrator effectively brings in the logic, right? But the individual building blocks are all modular and are all very easy to update, on a one-by-one basis.
Yeah. Can you elaborate on the only makes sense at scale 50 plus devs issue? Why not 40? Is this due to costs or something else?
Yeah, so I think the point here is that you can have one person running on an internal developer platform. And the question is like, well, what are the problems that you're trying to solve? And because again, I think like one of the challenges that we have sometimes in our industry when it comes to especially like infrastructure and operations teams. Oh, and by the way, sorry, the question earlier was also asking like, can this be done without infrastructure and operations team? Great point. No. I think that's what you see in that slide, right? You have the platform team / infrastructure and operations team, right? Are the ones updating these things, right? It's very, very important that you have a tight feedback loop between the platform team and infrastructure and operations team. And this is sometimes the forgotten, persona in the platform engineering journey, where we tend to focus so much on the developers, right, and the developer experience and developer self-service, which is the important thing, right? At the end of the day, the platform is about enabling developer self-service, is about reducing cognitive load, and about letting them move quicker without breaking things effectively, right? But again, platform engineering touches all these different parts of your organizations, and it's very important that everybody's on board. And certainly, it's very, very important that your infrastructure and operations teams are on board, because I've seen sometimes some dysfunctional dynamics between platform teams and infrastructure and operations teams, where platform teams are like, okay, like we're going to build this product and so on, but they're so focused on DevX, and they don't think about how this is going to impact infrastructure and operations team. Infrastructure and operations teams are not bought in, and then the thing doesn't go anywhere, right? And so it's really important that when you think about platform engineering, you think about kind of like DevX platform engineering on the developer side of things, and infrastructure platform engineering, which basically tries to bring in the point of view of infrastructure and operations team. And by the way, the platform, the way you do that is that the platform effectively becomes a sort of vending machine layer for their infrastructure, right? And removes all this like inbound ticket ops and requests from developers. They can just now work on actually like optimizing the scalability, availability, and so on. They can add new pieces of infrastructure, right? But they don't have to worry about provisioning the nth instance of a Postgres for the nth time, right? Which can become very frustrating and creates all sorts of friction in the system. So that was just like a side note. To go back on the team size question, the key thing here is, what is the problem that you're trying to solve? And the problem that platform engineering really solves is, again, this like lack of self-service and massive waiting times for developers that constantly get stuck and so on. And on the flip side of that is all this like manual configuration that is needed by infrastructure and operations team. And they've really become a bottleneck in most cases, and they're under pressure. Then you also have like shadow ops that happens on top, right? Because the infrastructure and operations teams are so bottlenecked and under pressure, developers basically, resolve to have like maybe their more senior colleagues kind of like jumping in and doing operations and sort of like doing this like shadow operations. And you have all sorts of like dysfunctional things happening, right? And so that's what you're trying to solve when you build an internal developer platform. Now, I think so by building an internal developer platform, effectively what you enable is true self-service, true DevOps in a way, right? At scale, right? At an enterprise scale for very complex setups. It doesn't matter how complex your setup is, cloud native, hybrid, on-prem, whatever, it doesn't really matter, right? That's what platform engineering enables. But if you are 10 people and everybody actually is familiar with your setup, can handle all your Helm charts and all your Terraform and so on, you can actually do real DevOps, right? As in like everybody does both dev and ops. The point is that doesn't scale, like, right? It doesn't really scale past, like that's sort of like 50, 100 developers mark, right? That's when you're basically, especially if you're like growing and your setup is becoming more complex, you're going to have new developers that come in. They're like, hey, I have no idea, like, or I'm just like a front end. I don't want to deal with like what Pulumi script is calling which Terraform calling which Helm chart and so on, right? And so that's where you then you basically see those issues. So you can do platform engineering at any scale, but the reality is that the pain points that platform engineering addresses are more and more felt at larger and larger scales.
Cool. Maybe one last question. We recently wrapped up PlatformCon. What was like the key takeaway for you personally from organizing the biggest platform engineering event?
Is this a question from you or from the audience?
For me.
So what was the key takeaway? I think from a content perspective, I really thought that the Q&A between Kelsey Hightower and Casper was incredible. So I highly recommend everybody go watch that, and we can share it in a follow-up maybe tomorrow or I don't know now, maybe if you find it, Maria. But I think what's interesting for me is to see the development of PlatformCon, and it's pretty crazy to see how much the standards I was mentioning earlier are compounding year over year. So I think the most watched talk, or one of the top 3 talks from PlatformCon 23 was actually this about this reference architecture that we launched together with McKinsey back in at the beginning of last year. And it's crazy, that was kind of like the first time that we were really like publicly talking about that. And at PlatformCon 24 this year, I think like 20+% of all the talks were building on top of these reference architectures, which is amazing to me. And it really speaks to the fact that we're really maturing and we're really like paying attention to standards and I think evolving the discourse and the conversation here and raising the bar year over year. But also that I think this means that whatever was hottest this year will probably become kind of the a reality next year or a very established trend next year. And this is why I wanted to talk about graph-based backends today, because that's effectively what you're seeing. I think one of the clear factors is that now you have, as the space matures, more and more people are looking at platform engineering and they're starting to ask the right questions, which is like, okay, I mean, I could just put a portal something on top, but like this is just gonna get me like 2 months, and then what? Like what have I actually solved? And so people are really, I think, double clicking on what are the real pain points that we're trying to solve, and they're realizing it's at the end of the day usually boiling down to a lack of automation and a lack of cognitive load on the development side of things, and a lack of standardization on the infrastructure and operation side of things, right? And that's where they kind of take a step back and like, okay, well, backends is really how we solve this. And so I think we're going to hear a lot more about this idea of backend driven design for internal developer platforms, and people just, again, as we mature, just treating them more as we treat everything else, right? You build an application, you start from the backend, and you pick the right backend, and the same I think is going to be true for platform teams and platform engineering teams, and that's what we'll see next year. The other last thing that I want to leave everybody with is this. I think this community really started virtually during COVID, and I've seen an amazing evolution over the last 3 years of basically this beautiful hybrid event, PlatformCon, but also the community broadly. We now have virtual events like this one every week, but we also have in-person events that we're organizing all over the place. And PlatformCon, I think, is the perfect representation of that, where you have, the virtual component that now reaches almost hundreds of thousands of people, which is crazy to think about. But then you have this pocket of amazing in-person community. We had the first live day this year in London, which was really a true highlight, and a place where I've seen all these people coming together, and and the quality of the conversations was super high. And so that's also what I'm really excited about. I think there's going to be more live days to come. Spoiler alert, and so I think that we're just getting started with this community. So I'm really excited to see what comes next.
Cool. And by the way, if you're still not a part of the community, here is the link once again. And if you have any follow-up questions regarding this talk, please just join the community.
You find me in the Slack.
Yeah, Luca is there every day, every minute, 24/7. So you can bother him there. But with that, I think we're a little bit over time. But thank you so much for sticking around with us this evening. Hope you enjoyed the presentation, and we'll follow up with the recording and slides, so you'll receive it in your inbox tomorrow. I'll see you guys next week. And hope everyone has an amazing end of the day. And thank you, Luca, once again.